Yeah, so today I'm going to be talking about building shareable GitHub Actions workflows using CDK. It's quite good that I'm following Steve's talk because Steve told you pretty much all there is to know about GitHub Actions. And yeah, it's awesome that he showed you some of the best practices for securing your GitHub Actions workflows. So yeah, makes sense. Hopefully if some of you were in the room for the previous one, then yeah, a lot of this should be quite introductory in comparison. But yeah, I think there's something in it for everyone to learn. So yeah, quickly, who am I? So my name's Joel Hamilton. I work for a company called Alios. I'm a developer. We're a consultancy. We help people adopt serverless. I'm also part of the AWS Community Builders program, part of the serverless track. I also organize the Serverless London meetup. I know I'm in Manchester right now, but if ever any of you ever find yourselves in London and have an interest in serverless, then definitely do pop by. I've also contributed to the Serverless Transformation blog and also to SLS Test Tools, which is a testing framework for serverless infrastructure. And yeah, I like to have the slide in pretty much all my talks just in case people have different ideas about serverless and what it means. This is pretty much my definition, so whenever I reference the word serverless in the talk, this is what I'm talking about. To me, serverless is just an approach to designing software in which you don't need to think about servers. Any aspect of server management, so scaling, managing capacity, security, most of that lies with the cloud provider. Close to infinite scalability. Also, you can scale to zero, so the next point is pay for what you use, which essentially means if you deploy some infrastructure and you never use it, then it's not costing you anything. And the other thing is, developers, when building on serverless, can focus on delivering value and less on aspects of server management. So that's what serverless means to me. Here's some examples of some of the main AWS serverless services. So I'm sure most of you will be familiar with most of these. There's API Gateway for routing HTTP requests. There's AWS Lambda, which is function as a service. There's DynamoDB, which is a NoSQL data store. Step Functions, my personal favorite service, which is a workflow configuration service, and Simple Queuing service. So yeah, so let's talk about some problems faced by large orgs. A lot of these problems that I'm going to mention become quite apparent when undergoing major digital transformation, such as adopting serverless. So many large organizations, especially when they have multiple tech teams, struggle with things like maintaining code consistency across all the projects, all the repositories managed by all the teams. Also things like enforcing best practices across all teams. As well as also just in general, trying to reduce cognitive load on teams. So like many teams in the same organization end up making the same learnings multiple times. You have 6 teams all making the same learning. It's quite a lot of it's a waste of time, but also a waste of cognitive load, trying to have these learnings and make these realizations that were made by the team just down the hall, possibly a year ago, a few months ago. So yeah, I think the solution is that you need to structure your teams optimally in order to tackle those issues from day one when undergoing digital transformation. So how do we structure teams optimally? Obviously, it's quite subjective how you structure teams optimally. But the way I suggest doing it is by using team topologies. So Team Topologies is a book. I'd highly recommend it. In it outlines a few different types of tech teams. I'm going to focus on 2 of the teams because that's something we've been doing recently on a big project. So the one type of tech team is called a stream-aligned team. It's kind of in the name. What it basically means is it's a tech team focusing on an individual segment of the business domain. So one bounded context. And they essentially deliver a flow of work, every bit of work relating to that bounded context. Then there's a platform team. What a platform team is, I have the definition here. It says it accelerates the streamlined teams via a product-based approach while maintaining their autonomy. That's a bit wordy. What it basically means to me is that the sole purpose of a platform team is to empower a streamlined team to deliver value quicker and more easily. So yeah, so quick aside, I added these slides in because I was at a conference the other day and a lot of the code examples were in the serverless framework, and my code examples are in CDK, so I figured it might be good just to touch on a bit of an introduction to CDK for those of you that haven't used it. So quick show of hands, who here builds serverless software, I guess. It's a good way to ask it. Cool, so that's a lot of you. Who here uses the serverless framework most of the time when building serverless software? Okay, so a few. Yeah, who here uses CDK a lot? Cool, nice. Okay, cool, a good mix. Say about, 40 to 50%. So for those of you that have used CDK a lot, the next slide or 2 might be a bit introductory, but that's fine. So what is it? The AWS CDK is a form of infrastructure as code. It uses common programming languages. So that screenshot comes straight from the AWS docs. I think since I did the screenshot, the CDK might be supported in other languages. I'm not quite sure. It seems that every other day they're supporting something new. So these are all common programming languages that we're all familiar with. Some of them we've learned in university. What CDK basically allows you to do is it allows you to create AWS infrastructure by just instantiating classes in code, right? Things that a lot of us learned to do in university. So in Java or TypeScript, you'd use the new keyword. But it's reducing something slightly advanced, which is creating AWS infrastructure, to something more simple that a lot of us know and can understand. This is a screenshot also taken from the AWS docs. I wanted to just talk here because I start using these terms kind of like a lot in my talk, and I figured it'd be good to just take a second to explain. This is the anatomy of a CDK application. You could say it's the anatomy of any application sort of built in, which is cloud native. But all these words also correspond to CDK classes. So you have an app, that's any application. In an app, you have a stack or multiple stacks. And when I say that, I mean literally you will import the stack class and instantiate it. And then in stacks, you have constructs. And what a construct is, I'm going to dive into the various types of constructs now, in fact, on the next slide. So I'm not going to dive into what constructs are while I'm here. Just quickly, what I like about CDK is that when you use a typed language, it gives you the benefits of like consistent code readability, rapid code navigation, right? Because you can just like command click on a type and move through and look at all the different types needed for like various arguments to various whatever you're passing in. It's also increased IDE support. I love the screenshot. It's like my go-to. I have it in an old slide deck, and it's just like showing autocomplete. And it's just like, isn't that gorgeous? Just having autocomplete on absolutely everything. And also, now also the same language, right, can be used for front-end, back-end, and even for CI pipelines if you're using something like TypeScript. So how do platform teams leverage CDK? This is where I'm going to explain what constructs are. So CDK infrastructure is defined using constructs, as I said, and these are just classes. And this allows for varying levels of abstraction. And what these layers of abstraction provide is the ability to hide complexity, also to provide sensible defaults for your infrastructure, which might not be there if you were using something like CloudFormation, as well as enforce best practices within and across teams. As I said, also, by the way, I put the 3 letters OOP there because I had a bit of a blank space. And obviously, because I keep talking about creating new classes, I'm like, hey, this is object-oriented programming. Let me put the letters there and really show it to the crowd that I know what I'm talking about. As I said, 3 layers of abstraction. How's this done? This is level 1. So we have level 1 constructs, or layer 1 constructs, I should say, L1. And what these are essentially direct mappings to AWS CloudFormation resources. So here you can see we're just instantiating a new bucket, so an S3 bucket, and you can see the construct is called a CFN bucket. So it's a direct mapping to CloudFormation, and there we've passed in just the bucket name, but obviously there's a whole bunch of other configuration we could be passing in for it. The next thing is an L2 construct. This is slightly one layer above L1 constructs, where a construct still represents only one piece of AWS infrastructure, only one resource, but it provides some things like some boilerplate code, and also just like some functionality on the class. So like you can type in the class, it'll have some built-in functions, which is super useful. So for example, if you're creating an API gateway instance, you'll create an instance of the REST API class. It also then has functions like .add resource, which is for like adding a new resource to your API, which then will have its own get and puts and things like that. So it's quite useful, as well as also these L2 constructs will have some sensible defaults that the L1 constructs don't have. So I also mentioned here, there's also L2 constructs. Sorry, I'm coming back to that slide. That's supposed to be next. Anyways, this is kind of the hidden layer of abstraction. So I said there's 3. Spoiler alert, I was lying. This is the middle one. So it kind of slots in there, making it 4. This is an L2 construct. So what an L2 construct is, it's like an L2 plus construct is, it's like an L2 construct, but it's custom. So it, again, provides defaults, bakes in some best practices. However, this is something that you will have written yourself, not something you will have just imported from the AWS library. So as I said, these still represent only individual cloud resources. But what's quite cool is you can enforce specific characteristics for these resources, which may be specific to your code base as a whole, or your specific team, or something like that. And we just do it simply using OOP by extending classes of L1 or L2 constructs. So this here is an example of a Lambda construct, which only works for specific node versions, right? So as you can see there, it says Node.js function. So that's an L2 construct I've imported from the AWS library. You can see I've created my own class, which extends it. So it's a child class called ComSumLambda. And yeah, then in the constructor, which is basically what happens when I create an instance of this class, I check, has a runtime been passed in? Okay, if it has been passed in, is it node version 16? Yes, it is. Awesome. Call super and create your Node.js function. Else, a runtime's been passed in, but it's not Node.js 16. We complain. We say, nope, sorry, ComSumLambda functions must all use node version 16. And you can see here at the bottom part, that's what I mean by a sensible default. When a runtime is not passed in, then by default, we just make sure that the runtime being used is node 16. So this is quite cool, quite a cool, neat way of enforcing that your team uses node 16. So yeah, so quickly, also, I hear I could have, like in a fancy way, just stopped them from passing in a runtime or something like that. But for this specific example, I think it's quite cool just to show you how some logic can be put into child constructs just to essentially make your application more consistent throughout. Because now any application using these constructs is not going to have a Lambda function with any runtime other than node 16. And quickly, here's another example. If we had an S3 bucket, we extend the S3 bucket class, we can add some pretty cool things, like we could block it from being a publicly accessible S3 bucket. We could also add a specific encryption standard, or yeah, I can't remember what I meant by the last thing. I think I left out a word. But yeah, anyways, this again would just be done by extending the bucket class and creating your own custom L2 plus construct. So yeah, so then there's L3 constructs. And what this is creating a custom construct which abstracts over multiple AWS resources. So, for example, you might have a construct which, when instantiated, you want a Lambda function to be created. But with the Lambda, you also want an API gateway endpoint to be created. Maybe you add to the props of this custom construct the actual API gateway instance, and all you do is add an endpoint for this specific Lambda. You also might want a CloudWatch dashboard widget to be created for the Lambda, or who knows, maybe the Lambda gets its own dashboard. You could spin that up inside the custom construct as well. I've also referenced CDK patterns here, just by, I put a screenshot here, and I definitely recommend checking it out, because what's quite cool is on CDK patterns, you have a whole variety of constructs, L3 and others, that are like already, they've been audited, they are well within the well-architected framework from AWS, which is very cool. And also they're used quite a lot, so clearly they're pretty useful patterns and can save you a lot of time and give you a lot of ideas when you're building your own software. So yeah, so how do we share CDK constructs? So yeah, one way of doing it is to just export your constructs in an index file and yeah, publish a package basically, so a private NPM package or a GitHub package. And then yeah, then from then on you can just import it into all repos which use the constructs. Another thing you could do is I guess you could have like a monolith or like one mono repo with a ton of other repos and you just sort of export it, but that doesn't scale very well with multiple teams and multiple repositories. So yeah, so how in general do we share CI steps? So I just want to quickly touch on CI and serverless projects in general. To me, continuous integration is integral to all projects. It allows for things like a quicker time to actually merging code in, less time to deployment, more frequent deployment. And also, when it comes to doing CI and serverless projects specifically, I like to use a thing called serverless flow, which essentially uses serverless and the ability to just spin up a new stack and a new environment to its advantage by creating rapidly deployable, cheap, and disposable environments. So in this case, it would be CloudFormation stacks generated from CDK in order to preview branches before merging into main. But for more on this, definitely check out this article by Ben Ellaby. I think he's somewhere in the room. And yeah. So how do we reuse, as I said, how do we reuse CI steps and workflows? So many steps in I really could have made the font bigger on this one, I apologize. Many steps in a CI workflow are sometimes the same across like multiple workflows. So for example, in lots of CI workflows, no matter what the trigger, whether it's creating a PR or pushing to main, like you're probably going to install some dependencies. There's probably going to be some sort of build command. Very often you'll be running tests. Some other examples are like deploying stacks or running linting rules. Another thing you sometimes have to do for like security purposes is checking that the correct or latest version of specific dependencies are being used, etc. So there's a lot of overlap between many different CI workflows. And this overlap is almost like extra when it's within an org and you have multiple teams all doing like org-specific actions all the time. So how do we share steps? So if you're familiar with Circle CI, you'll know Circle CI orbs exists. And this is a great option for using Circle CI, for teams that are using Circle CI. Currently, I'm not using Circle CI because I'm a big fan of having an interface where you can view the code in the same place that you view your workflow. So I've been opting for GitHub Actions. As if you were in the room for the previous talk, you would have learned all about GitHub Actions. GitHub Actions is awesome. It basically allows you to run your workflow in the same user interface as where your code is. What's also cool is in terms of reusing actions, there's a GitHub Actions marketplace where you can search and find an action. And if you find it, it'll have an action ID or an action name. And basically, in order to use it in your own workflow, if you're writing some YAML, you just have the word users, a colon, and the ID. And essentially, when you push up your workflow to GitHub, it'll go and fetch the action and perform it, which is awesome and great for reducing code duplication, essentially. Then there's also the native AWS tools option. So, if you're using things like AWS code pipelines to configure a code build instance, which is going to like build and test your code, and a code deploy instance to actually get your stack deployed. What's quite cool is because it's AWS, there's going to be AWS constructs for these. So again, here you could take a similar approach. You could just, to the CDK approach of creating constructs, right? You create your own custom CDK construct, which are wrappers / extensions of these constructs. And yeah, you can export them in a GitHub package, or as I said, if you're in a mono repo, you can just write the word export and use them in another file. So now I'm going to be talking about I'm sort of merging the two ideas I've been speaking about. How can we create GitHub Actions pipelines using CDK? So there's a package called CDK Pipelines GitHub. It's very cool, and the steps for creating a GitHub Actions workflow is awesome. Basically, all you need to do is define your workflows in CDK. I'll show you some code examples now. You then run CDK synth. What the CDK synth command does is normally it synthesizes a CloudFormation template, so basically transpiles your CDK code into CloudFormation. You can then push it up to GitHub and you trigger it essentially, because when you run CDK synth on these CDK pipelines GitHub constructs, what it does is it actually generates a .github directory, and inside it will have a workflows directory and a deploy.yaml file. So instead of having to write all this raw YAML yourself, you've generated it using code that you're a lot more familiar with. So here's some code. I'm going to walk you through it. This is creating a GitHub Actions workflow in CDK. So you can see I'm creating something called a PR workflow. I'm instantiating the GitHub workflow construct. So that's a construct I've imported directly from the CDK Pipelines GitHub package. You can see my synth step there. So that's where I'm going to synthesize my template. I'm passing in a GitHub action role on. I had to take my real on out and just put it in there because obviously I don't want everyone to have access to my resources. And then then there's also here in the bottom you can have your workflow triggers. So for this specific one, it's triggered by opening a pull request, reopening it, and synchronizing on the pull request, as well as pushing to main. In fact, I know it's called PR workflow, but I wanted to have that trigger there so you could see how you could create a trigger on a push main workflow. And then at the bottom, you can see I have what's called pre-build steps. And these are the steps used before you actually build and deploy. And at the bottom there, that screenshot, sorry for putting it like right at the bottom, hopefully you can all see, of the generated YAML file. And what that is that's the action that is used in order to actually deploy your AWS resources after the CloudFormation template has been synthesized. So how do you create CI steps specifically using this package? So here it's quite easy. They just have a TypeScript interface called job step, and you just create a job step. These two examples were chosen quite specifically because the one you can see is just clearly like some shell command. So it's just npmi, you want to install your dependencies, or you could also run yarn, something like that. You also give it a name so it's nice and clear when it's actually in the user interface. And then the next step, that's an example where I'm actually using a GitHub action from the marketplace. So this isn't something like I wrote. This, in fact, is an example of using Amazon Code Guru to review your code for you. So yeah, all I did was like typed in Code Guru on the marketplace, went and got the ID, and chucked it in my YAML file. So these are two examples of steps which you'd be able to put in your pre-build steps array when creating a GitHub workflow. It also has post-build steps, so in case there's any cleanup work or anything you want to run after actually deploying your AWS infrastructure, then you can also do that. So yeah, sharing CI in general. How do we create reusable CI steps, right? So as I said, these aren't CDK constructs. These are just TypeScript interfaces. So if I just put the word export in front of both of those, all of a sudden it's reusable, right? Because you can use it. But obviously, if you want to have a package, you'll need to run export, and you'll need something. If it's a TypeScript package, you'll need a tsconfig, you'll need a build command, and you'll need to actually publish it through something like npm or GitHub. But how do we create reusable entire GitHub Actions workflows, right? The answer is to create an L2 plus construct. So yeah, I'm sure that you can read that, hopefully. So quickly, I'm going to walk you through this code. And what this is an example of me taking the GitHub workflow construct and trying to make it more reusable. So what I did was I extended the class, right? I called it PR workflow. And then in the constructor, I basically just call super with all the same props as when I was creating the GitHub workflow construct itself, right? So I mean, as you can see, most of that code there is copy and pasted, except the pre-build steps have changed. I'm now using the job steps from the other slide. But what's quite cool is that now you have a class, right? So classes can be shared. You just import the class, you create an instance of it, and it's pretty easy. So here I am calling new with my own custom class. Wasn't that much extra code, but it's a lot less code if I wanted to reuse it, right? Like if somebody else in another team or in my team wants to create a similar workflow, or the same workflow, basically, all they need to do is import the class PR workflow and have this small amount of code, as opposed to needing to go back and copy and paste all that code from creating the GitHub workflow construct itself. So yeah, as I said also, you create this instance. All you do is you run CDK synth, and it generates the .github directory for you. And when you push it up to GitHub, your workflow will appear. So yeah, so what's the result? I had to be careful here taking some screenshots because I just didn't want to take a photo of anything like private, like from my company. But so yeah, so like these are the actual, like a whole bunch of workflows, right, generated using CDK pipelines GitHub. That's the path of like where the YAML file gets created. You can pass in your own path, by the way. So if you want like a custom path, you want to have separate actions be in separate directories, you want to give your YAML file a different name, something like that, then that's all more than possible. And then yeah, then essentially, here's the workflow run steps, right? And as you can see, there's little arrows, which is cool because it means you can, on the side, sorry, I know it's a bit small, but you can click on it and you can look at the specific job steps which you've passed in and see which one failed. And yeah, so if we're sharing these across teams, as I said, I'm quite a fan of just releasing an NPM package. If you need it to be private, make sure it's a private NPM package, please. Or use something like a GitHub packages, which you can use the NPM registry behind the scenes if you like. What are the pros and cons of doing this? I was at Bob Gregory's talk now. He's not a fan of just taking a problem and fixing it by creating a new package, which is fair enough. So one of the pros is that it scales really well, so it can be imported by as many other repositories, as many other teams as needed. It's also relatively simple to do. Maybe it's a bit complicated the first time, but once you've done it once, it's quite easy. And as a platform team, if you really are creating a ton of things to support your streamlined teams, that actual flow of working out how to share things across a whole bunch of teams will be a teething issue, but it'll be something you'll get quite used to quite quickly. What are the cons? So some changes, like if you need a change made to the actual like package published by the platform team, this might require a PR to the package repo and a PR to the repo using the package, which is obviously not ideal. So for that reason, if you're a small amount of teams, like it's probably not necessary because the scale benefit doesn't really apply to you. And also it can cost money, and it's possibly more expensive than alternatives. You know, maybe it's cheaper to have a mono repo and just have everything there and not need to publish a whole bunch of packages. But at the same time, as I said, that does not scale when you're dealing with hundreds of teams. And obviously the alternative options are also kind of limited, right? As I said, mono repo is an option. Another thing I thought about is you could store the code in an S3 bucket and all repositories just go and download it from there. But then obviously every time there's been a change, you need to like send a Slack message being like, hey guys, the bucket's changed, download the latest version. It's not very formalized. But yeah, and the benefits to doing all this, like why am I giving this talk at all? It's abstraction, right? There's less cognitive load on dev teams. Dev teams don't need to worry about having all these learnings related to when it comes to creating workflows. And especially, they don't have to worry about having the same learnings that another team has just made. It's also more consistent, right? You have multiple devs and multiple teams in a large organization. And now at least they're all using the same constructs, less room for code inconsistency. And also security is a big benefit, right? All the best practices that were spoken about in the talk before mine, these can be baked into CI steps, which are immutable. So it really does make things a lot more secure. And yeah, the bottom line is CDK allows for shareable, reusable, pretty cool CI with varying layers of abstraction. And sorry, by the way, there's an exclamation mark and an equal sign. And I know in code that means it's not equal to. But I did just put the exclamation mark there for enthusiasm. Yeah, and essentially it results in being able to empower streamlined developers to deliver more value a lot faster. So I'd highly recommend checking out the repository, and I'd love to take any questions. Do reach out to me on LinkedIn and Twitter. I'm relatively active in the community, and yeah, I love to talk about tech in general. And yeah, thanks so much for having me here, Phil and Joe. I've had a great day. Thank you.
Okay, wonderful. Thanks very much, Joel. So do we have any questions? Oh yeah, we've got one at the back there. After I walk to the front, of course.
Thanks very much. What would you say are the advantages to this approach in comparison to GitHub's reusable workflows that they have now?
So I think when you're a CDK-based platform team, right? So first of all, I think that's a great option, just to be clear. I think if you're a CDK platform team, you're used to doing things like creating custom constructs and sharing them, and like especially if you're training a lot of junior developers whose a large amount of their programming knowledge is it's quite almost fixated around object-oriented programming as a whole. I think the very object-oriented programming nature of it makes the learning curve quite easy. And I think that's certainly one of the big benefits. But I would by no means argue and tell you that the one is better than the other. Hopefully that answers your question. Great.
Any other questions? No, I've got a question then. When I've tried to do sort of reusable CDK things before, the very first parameter that a CDK construct takes is the stack itself, right? Do you not run into dependency issues? As I certainly ran into dependency issues between version 1 of CDK and version 2 around taking in that stack. Have you got any mitigations to deal with those kind of issues?
So yeah, I did actually run into something like that, and my answer was just that all the teams should just start using the latest version of CDK. Yeah, like sometimes a construct being passed in as a scope, it complains and says that there's a compatibility issue. I think you raise a good point in that if you're a platform team, you need to, you make your choice. You say, cool, we're CDK v2. We're using everything from the AWS CDK lib library. You need to make sure that all the streamlined teams got the memo, essentially. But also, hopefully, in a workflow that you created that they're using, it's going to check and be like, are they using the correct version of CDK? If they're not, fail the workflow. And when they're busy debugging their workflow to see why it didn't work, they'll get the memo, essentially.